In this video, we are moving on to different types of polygons. And in this specific chapter or lesson, we are on parallelograms. So I'm going to be doing some practice problems on those. But before that, let's quickly review the important ideas for parallelograms. Okay, so this is just taken from the book. Hopefully you can see the screen. Let me zoom in a bit even. Okay, and then, so I apologize if you see the glare. I'm trying my best here. Let me focus this a little bit. Okay, hopefully this is clear. Okay, so the important ideas for parallelograms, or the important things to know. Obviously, by the name parallelogram, the two opposite sides are parallel. So here is parallel to there, this is parallel to that, okay? So in parallelograms, so we're going over the properties, these two sides are congruent and these two sides are congruent, okay? It doesn't mean that these two sides are congruent, but opposite sides are congruent, okay? And opposite angles, so this angle and this angle with this angle, they're congruent as well, okay? Because of that, these two angles are supplementary. Okay? So angle B and angle A over here are supplementary. All right? And finally, the diagonals, they bisect each other. So this half of this diagonal is equal to this half of the diagonal, and this half is equal to this half. Again, doesn't mean that BE is equal to AE. Not necessarily true. Okay? And a special case of parallelograms is a rhombus. A rhombus is when all four of the sides are congruent. Okay? So that's a special case. And then not on here is another special case. A rectangle is when each of the four angles are congruent, which means that they have to be 90 degrees. Because remember, in quadrilateral, some of the angles inside the polygon must be 360. So if they're all congruent, 360 divided by 4, 90 degrees. And a special case for another special case where it's both a rhombus and a rectangle is a square, which makes sense. The angles in the square are all right angles, and the sides are all congruent because the length of each side of the square is the same. You probably learned that back in elementary school or something like that. Okay? So those are the important ideas. What does this one also say? Diagonals and rhombus are perpendicular to each other. Okay, that comes as a result because all the sides are congruent. Each of the diagonals, bisects. Okay, so I see, even I don't really remember this because it's a small detail, but you might need to know it. The diagonals bisect the angles as well in a rhombus, not for a general parallelogram though. Okay, and then the area of a parallelogram is the same as the area of a rectangle, base times height. Nothing new to remember there. For a rhombus, you can also find it by half times the first diagonal times the second diagonal. That's a different way. Okay, so now let's move on to the problems after we reviewed it. You can see I start labeling some things because I had a filming issue, but I'm going to redo the problem, okay? So this one tells us all these things, so you can pause the video to read all what's given, okay? We're asked to find what is the value of x, okay? So that's why I start labeling some stuff. We need x. X is related to one of these two diagonals, half of the diagonals. So we probably have to use that idea or that property that these diagonals bisect each other. We're given PR is 32, so we can write that. We know that x plus 2y plus this length tr is 32. I don't know if that helps us, but we can keep that in mind. And then we know that st equals tq. Again, the diagonals bisect each other. So maybe let's write that. So ax, if I can get the lead out. Sorry, give me. Having some technical issues here. I apologize. Okay, let me go get my pen. Okay, So where was I? I got my pen now. I was saying that we know that SQ, this half is equal to this half. So we can write 8x minus y equals 26. Okay? And then we are given PR, this entire lane. So what's half of PR? That's 16. This is half of PR as well. So x plus 2y is 16. Okay? We have a system of equations now. Two equations, two unknowns we can solve. So why don't I change this first guy to multiply it by 2 everywhere. So 16x minus 2y is 52, right? We add these two, that is 17x is 69, right? Not 69, that's 68. That the math out now. So then x would be 4. That looks right. Okay, let me check my answer. Is x equal to 4? Yes. Okay, so x is equal to 4. What's the value of y? Well, we can finish the system of equations. We found what x is. We can plug into the first guy or the second guy, doesn't matter. Let's plug into the second guy actually. 4 plus 2y is 16. 2y is 12. Y is equal to 6. Okay. Now, what's the measure of angle PQR? Where is PQR? PQR, this whole angle, 1 plus 2 over here. So how can we find that? There's probably multiple ways you can do this, but isn't angle 1 and angle 3, what's the term? Alternate interior angles? Something like that? Because these two lines are parallel. So this angle is congruent to that angle, is it not? So we can set a squared minus 7 equals 6a. We can solve this quadratic. A squared minus 6a minus 7 equals 0. So this factors to a minus 7, a plus 1 is equal to 0. So a can be 7 or negative 1. Okay. We probably want to just keep a equals 7 because if a equals negative 1, we would have a negative 6 degree angle there. That doesn't quite make sense. So let's just keep a equals 7. So measure of angle PQR, let's answer the question. We need this one, so it's 16a. 1 plus 2 is 16a, right? So what's 16? A is 7. So 16 times 7. What is that? That is 70 plus 42, right? Which is 112. Okay. Now, what is the measure of angle QRS? Where's QRS? QRS. This entire angle here. We don't need this for A, actually. Well, it might have helped with solving the other one, but we don't need this. Because we know that PQR and QRS are supplementary. So we can just do 180 minus 112, right? Which is 68. Okay. Now, what is the measure of QTR? QTR. Okay. Again, there's multiple ways that you could probably do this, but if we know this angle and this angle is just 180 minus those two, is what I'm thinking right away. Okay? That's one way to do it. Again, there's probably other ways to do it, but I'm just going to go with it because that's what I thought of first. Might not be the most efficient way, but that's okay. 10a, we found what a is, right? A was 7, so angle 2 is 70, okay? And then angle QRT is, do we know what this angle is? Well, we do, because we have, we just found QRS, right? which is 68. So 68 minus, what's 4a? A was 7, right? 28. 68 minus 28, that is 40. Okay? So angle QTR is 180 minus 70 minus 40, which is, I think, if I did it in my head, 70 degrees. And yep, that's the answer. Okay? So that's one way to solve this. Is this in focus now that I realize? Kind of is. Okay. Apologize if it isn't. It's kind of late now. Okay, so that's 1 through 5. You can see that in a lot of these geometry problems, you have to use previous knowledge as well. So like I had to use alternate interior angles somewhere here, and then you have to know how to factor. So that's why a lot of people struggle with a lot of these geometry problems. They forget previous knowledge that they need to apply in this situation. They need to combine basically multiple ideas or concepts into one problem, and then algebra as well. So you have to be good at retaining knowledge from previous topics. Okay, what is the area of the rhombus ABCD above? Okay, so we know that, well, this is a right angle, right? Angle E, no matter where it is. So I shouldn't say angle E because it's ambiguous, but DEC is ambiguous. I mean, that is a right angle. Okay? So we can use Pythagorean theorem to find this length, which is 3. 3, 4, 5 triangle. This is the easiest to remember. So this length is 3 as well, because by properties of parallelograms, these two diagonals bisect each other. So if this is 3, that's 3 as well. Now we can use that formula for area of a rhombus. Half times diagonal 1, which is length of 8, the whole diagonal. Diagonal 2, which is length of 6. Okay, this is 24. Let me check. Yes. Okay, so you kind of did it like that. I want to point out that you cannot, this would be 5, right? It would not be the same, clearly, if you did half times 5 times 5, because AD is not the height of the parallelogram. Hopefully you realize that. The height is always vertical. It's a vertical height. Just imagine if you're standing slanted and someone measures you top down, your height will be different than if you stood straight up. Okay, so a height is always with respect to vertical. Okay, and you can also, if you've gotten your height measured before, your doctor or whoever's measuring, like it's a common thing for doctors to take your height measurement. Just stand against the wall so that you're straight up and down, to the best of your ability, obviously. Maybe there's some curves and all that. That's it's the human body. It's not a rigid straight line, right? But anyway, besides the point. My point is, height is always vertical. So it's wrong to do half times 5 times 5. That's clearly not 24. Okay, last one here. In the figure above, PQRS is the parallelogram and PTS is the right triangle. What is the area of the parallelogram PQRS? Okay, so we're going to use what I just said. The base is 20, but the height is not 15. It's a vertical height. So this is why it says right triangle. We need this height of this triangle here. How can we do that? Pythagorean theorem. It will be 15 squared minus 9 squared is the square under the square root. That's PT, which is 225 minus 81. Okay. This is square root of 144, which is 12. So this length is 12. Now we can do area is base of the parallelogram, so don't count this 9, 20, times the height of the parallelogram, which is 12, which is 240. Let me double check. Yep. Okay, so lots of ideas that you need to remember for parallelograms, but they're not too bad, hopefully. All right, as always, please like and subscribe if you found this video helpful and you want to see more content like this. And please check out the SCT playlist to see more problem-solving videos of various topics.